Aurora's final Can-Am racers were the RC Cola Porsche 917 and Porsche Audi 510, numbers 1747 and 1786. Aurora marketeers cut a deal with Sears to produce the super hot Porsche Audi. Jim Keeler took the first shot of the 510K to Watkins Glen and showed it to owner Roger Penske and driver Mark Donohue. Keeler was amused when the conversation turned to whether the slot car's tiny, movable rear spoiler was functional. "I wish I had a tape recording of that conversation," Keeler recalled. Interestingly, Penske's real-life Porsche proved so dominant on the Can-Am circuit that it may have contributed to the series' 1974 demise. Emergence of the Orient. With the advent of AFX, only body design and pattern making remained at West Hempstead. Everything else, including manufacturing, had been transferred to the Orient. When Aurora engineers finished design work, patterns were air expressed to the Far East, where molds were cut, bodies were produced, and cars were assembled. Ratakowicz demanded that first painted prototypes be sent to West Hempstead for approval before production began. His reason? Hong Kong and Singapore graphic artists tended to orientalize decoration schemes. Actually, Aurora had begun transferring production to the Orient in 1968 when they purchased 49% interest in Johnson Electric of Hong Kong. This firm became Aurora's motor manufacturer, allowing West Hempstead plant managers to free up floor space for toy and game production. Then in mid-1970s, Aurora moved most production from Hong Kong to Singapore to take advantage of tax breaks. By then, the only remaining AFX manufacturer in West Hempstead was packaging. The Far East wasn't the only region to get Aurora's slot car business. Aurora's subsidiary in Rexdale, Canada, packaged model motoring sets, and a plant in Juarez, Mexico, contributed to AFX production by making controllers and track. The reason for Aurora's diversification was simple. Aurora had to internalize in order to lower costs and remain competitive, and in doing so, Aurora presaged the 1980s trend of overseas toy manufacture, a trend that today is a fact of American toy-making life. Thunderjets, end of the line. During the first 2 years of AFX, Aurora continued to list some Thunderjets in its catalog. After all, there was a huge T-Jet inventory in the Aurora warehouse. Keeler, literally mountains. And the West Hempstead toy maker had to get rid of it somehow. In fact, a large quantity of leftover T-Jet chassis compelled Aurora to design 4 new Thunderjet bodies for distribution in the toy and novelty market. The super-modified Roadster 1484 was only a slight departure from the slot car mainstream. Remarkably, it used the body of the ancient vibrator hot rod 1553-1365 from the early 1960s. The Sandvan Dune Buggy and Bushwhacker Snowmobile 1483 and 1485 were totally out of bounds. The Sandvans came in a race set with orange Baja-colored track. The Snowmobile came with snow-white track. These low-cost sets sold quickly and cleared Aurora's surplus inventory in short order. The final Thunderjet was also the cutest. Good Humor Ice Cream Truck, 1487. Aurora marketing managers cut a deal with Good Humor to produce 5,000 low-price sets for sale as premiums. Good Humor not only paid tooling costs, they even supplied a real-life truck to copy. The R&D staff drove it around the parking lot at the West Hempstead plant, burning rubber and ringing the bell, all part and parcel of standard model research. And that was the last of the Thunderjets. Super 2, Memoirs of a Teen Racer. AFX cars were becoming serious business for racer hobbyists. Not only were they doing well in the mass market, but the survivors of the large-scale slot car crash were adapting their interest to Aurora's innovations in HO. When the first AFX cars were tested by Car Model magazine, staff editors determined that the AFX could match or beat Tyco Pros in every department, except top speed. Reason? Superiority of the can motor over Aurora's pancake design. Of course the motor made little difference on home tracks where speeds were slow. Most important, the slight Tyco Pro speed advantage meant nothing to the millions of kids who got Aurora sets for Christmas. And Aurora was still as dominant as ever when it came to mass sales. Hardcore slot racers, those who were now HO enthusiasts, were a different story. Generally speaking, these hobbyists used can motors like Mabuchi's and Tyco cars. With such a motor chassis combination, it seems obvious that the Tyco Pros would dominate their Aurora counterparts. And nowhere was this more clearly demonstrated than at a summer 1971 race held at Brooklyn's Buzzarama Center. 32 can motored cars were matched against just 2 cars with Aurora Thunderjet motors. However, to the amazement of everybody, one of the Aurora-powered cars easily defeated the field. The winning driver, Brooklyn High School senior Tony Porcelli, one phone call from Buzzarama to Keeler at West Hempstead, and the Aurora slot car product manager was asking Porcelli to join the Aurora team. As soon as he graduated from school, of course. With Aurora's sponsorship, Porcelli racked up wins on the slot car circuit with his modified AFX. Meanwhile, West Hempstead R&D went to work on a new AFX production car that incorporated Porcelli's innovations. It was intended to be a prestige item showcasing Aurora technology. Marketeers planned to introduce the new car at the 1972 HIAA show as the fastest slot car in the world. However great a promotional idea it was, Porcelli finished second at the year's final race. Between races, Porcelli worked at the West Hempstead plant with the R&D team. He recalls how much he enjoyed working with other enthusiasts. Great esprit de corps prevailed among the R&D staff. 18 men who labored in an exciting work atmosphere and proudly wore team blazers and lapel pins. Outside his department, however, Porcelli found too much dissension and infighting. We butted heads regularly with engineering and marketing, he recalled. As a result, Porcelli's modified AFX car turned out to be a real nightmare. I did all the work on the prototypes, designing them, building them, and racing them, and turned them over to engineering. R&D was still supposed to work with engineering, but there was a lot of friction between the two departments. The car based on Porcelli's design differed greatly from the car he had been racing. I was disappointed. I really was. The altered Porcelli design debuted at the HIA convention as the Super 2, 1788. Car models Howard Kilgore ran the prototype at the show, and his reaction was very positive. Saying the car is a pleasure to drive is an understatement. The sensation of controlling an HO car with blinding speed and superb handling characteristics is pure enjoyment. The car will compare with the very best scratch builds when total performance is considered. Aurora slot car chief Jim Keebler labeled it a holy terror. The Super 2 resembled Tony Porcelli's prototype, but changes have been made to accommodate mass production. Lead weights were installed differently. Certain metal components were too soft. Braided copper pickups were terrific for electrical pickup, but turned into a matted mess with use. Most disappointing were the rear tires. They were supposed to be wide and soft, but were too narrow and too hard, and the motor was just too much for the tires. The slot car community's chief criticism was the car's price, $12 compared to $4 for a regular AFX. Some wondered if AHO racing would price itself out of existence just as 124 cars had. But despite its problems, the Super 2 kept up with the best scratch builds, and the kids didn't have to be experts to keep it on the track through the curves. Dale Flanagan of Car Model, October 1972, concluded, "Whether it's worth a $12 price tag is something you and your banker will have to decide." The Super 2 would last only 2 years, 1972 and 1973. High Performance Track. Aurora built its most elaborate slot raceway ever for 1972's New York Toy Fair. Showcasing the Super 2 was a beautifully landscaped 3 by 16-foot monster of plywood, chicken wire, and plaster. The road course climbed up and around a foot-high mountain with a 4-lane speedway oval with banked curves nestled in the valley below. More than just a showcase for the Super 2's speed, the layout highlighted the introduction of Aurora's high-performance track. Since the days of the vibrators, Aurora had been praised and damned for its track system, great on variety but deficient in terms of performance. And as car speeds increased, track quality became increasingly important. Aurora's answer was high-performance track. Some changes were purely cosmetic, like eliminating the white middle-of-the-road line found on Aurora tracks since the days of highways. Engineers added a deeper slot to accept new blade-style guide pins. Most important was R&D team member Lou Ocasarno's interlocking tab track connection system. Finally, an end of Aurora's pins and clips. Assembly and disassembly was quicker and sections fit together more precisely, improving performance. 1973's Quickie Lock tool made assembly even easier. The most dramatic innovation of high-performance track was banked curves, something hobbyists had requested for years. Aurora offered 4 different kinds: banked S-curve 2543, shallow curves that created twisting S's on a straightaway, hairpin curve 2544, a steep bank 6-inch radius 180-degree turn, and the 9-inch Monza bank curve and 12-inch Daytona bank curve 2467 and 2545, which could be used side by side to make a 4-lane track. Aurora encountered tremendous tooling and manufacturing problems with bank curves, which is why no other company had attempted the products. Indeed, the hairpin curve was simply too abrupt, causing cars to fly off at normal speeds. It was discontinued in 1974. In addition to the Super 2 and high-performance track, Aurora had one more 1972 innovation, the Diagnostic Center. 4 components that helped the slot car hobbyist fine-tune his HO cars: the weight analyzer, power control, dyno track, and the never-produced tire balancer, numbers 1546, 1544, 1545, and 1547. They weren't hits with racers like Pacelli and designers like Rotakowicz. They considered the devices too crude to be of any value, but Aurora executives insisted they go into production and that they be inexpensive for toy market appeal. Unfortunately, nobody bought them. Serious racers knew they were useless, and kids who play with slot cars as toys didn't want them. Accelerators, innovation never realized. Since the days when electric slot car sets first achieved success, Aurora designers dreamed of miniature cars running free around the track, unshackled from guide pins and slots. In the early 1970s, Aurora initiated a top-secret program in cooperation with Bell Laboratories to develop a computerized slotless system. Only Jim Keeler and a handful of Aurora executives knew about this black project, though it cost Aurora a serious amount of research money. Eventually, the effort was abandoned. It offered no realistic hope of a low-cost product. But innovation was out there, and it emerged from a source Aurora least expected, Montgomery Ward. The retailing giant had been offered a slotless racing concept by an independent toy designer. Ward management went to Aurora and suggested that he produce the set as an exclusive for the Ward catalog. Jim Russell, who handled the Ward account, looked over the slotless racing system and pronounced it Mickey Mouse. However, when Ward insisted they wanted it for their 100th anniversary catalog and would pick up initial tooling costs, Aurora went for it. The result was Accelerators. Aurora proclaimed the arrival of controlled racing, including authentic lane changing and passing. R&D racer Pacelli recalls the vast amount of work Aurora put into the system's bank, track, and electricals, but it never worked properly. The idea was to create a high-speed outer lane and variable speed inside lane between which the cars would alternate. Unfortunately, the T-Jet motor lacked sufficient power to maintain speed, causing the cars to coast between power rails. Worse, the pickup shoes dragged, further slowing the car. With enough deceleration, a car could get stuck between power rails in a stall. Once the cars were underway, the only logical strategy was to hold the throttle full open. High outside lip of the track eliminated wipeouts. When Aurora showed accelerators to the 1973 HIA show, Russell installed 4 power packs in tandem to raise track voltage high enough to keep the cars going. We were burning up motors right and left, he observed. Aurora, of course, had plenty of spare cars on hand to make up the losses. Would America's kids? The appropriately named Demolition Intersection of 1974 gave the set its only exciting angle. Accelerators 2, introduced in 1976 with G-Plus motors, promised faster cars and easier setup. However, toy industry journal Plaything soon noted the set's high return rates. Accelerators were moderately successful as toys, but they were never taken seriously by hobbyists.